So good morning again. This is the second of two trainings. It's a package of trainings that we decided to give this week on two open source software tools and their implementations that we use within INSPIRE. On Wednesday, there has been a training on the INSPIRE registry and the registry software. Many of you were there, I'm sure. Today, the training will be a similar one on the ETF and the INSPIRE Reference Validator. Very important point, these trainings are for everyone. So whether you have never heard about the ETF and the INSPIRE Reference Validator, or you are an experienced user, or you are a developer, or you are an administrator, this training is for you, in the sense that we will try to cover all the needs, again, from people that would like to start using it to people that need to further develop customized tests, for example, in the validator, or administrators that need to deploy the validator at their own premises. So we will try to cover all those needs. Please be patient if there are parts of the training with which you are already familiar, or parts of the training that are not for you because they are too complex. Please use the opportunity of the chat of the Q&A session to ask your questions. So we will try really to cover and to address all the needs. The idea of the training is to provide a mix of, let's say, theoretical notions and more in the second part, hands-on demonstration. And you see on the right-hand side of the slide the agenda for today's meeting. I will give the first introduction to the two tools, the ETF and the INSPIRE Reference Validator, so more from a business point of view. This will be followed by a more technical perspective. Then we will have a coffee break, and after the coffee break, we will start the more hands-on part, and we will close with a Q&A session. The timing you see here in the agenda are indicatives. We will again decide to have a Q&A session before the coffee break, so we will see how it goes, but for sure we will finish before 12:30. Having said that, let me really start with the actual content. So the introduction from a more business point of view on the ETF and the INSPIRE Reference Validator. So the context is the publication of resources in a spatial data infrastructure. And I'm sure all of you work in this domain, so you know very well that many things can go wrong when you deal with the process from data collection to data harmonization to the data publication on the web. First of all, you may have issues in your data, either in the raw data or in the harmonized data. You may have issues in the tools that you use for harmonizing or processing data, in the ETL tools, or in the geospatial server, so in the services that you use to expose your data. You may also have issues in the software themselves, not just in the way you configure the software tools. And finally, you may have issues that are related to your specific infrastructure. So for all these cases, and to spot, to identify the issues and to hopefully help you fix them, there's the need for a validator. And the ETF is exactly the open source testing framework that we will present you in this training. And it's a testing framework that allows you to test and to verify the conformity of geospatial resources, so data sets, metadata, and web services as key building blocks, let's say, of an SDI. I have a video to play. It's a 2-minute video that just really introduces at a very high level the software, and then we will come back to the slide. Let me play the video.
Do you manage digital assets and need to conform to technical specifications on a day-to-day basis? ETF can help you with this. ETF is an open-source testing framework to validate datasets, metadata, web services, and APIs in the geospatial domain. It is co-funded by the Digital Europe program of the European Commission. Conformities check against a set of predefined tests. These are developed and loaded into the software. The tests are known as Executable Test Suites, or ETS. You will find built-in support for geospatial standards, but the ETS are fully customizable to fit your needs even beyond the geospatial domain. Just prepare and upload your own test units. ETF provides you with a detailed report with pass and fail tests, so you may understand how well your data is doing and how to improve it. ETF is already used by a diverse community. For instance, European Union member states use it to implement the requirements of the INSPIRE directive. Similarly, member states' public administrations use it to address country-specific requirements. Finally, private companies and solution providers integrate ETF in their end-to-end products. Getting started with ETF is easy. Download the source code and follow the installation steps. You can also use the ETF through its API to automate tests or validate large amounts of resources. Do you need help? Did you experience an issue? You can ask questions in the issue tracker on the ETF public repository. Reach out to the ETF community. You are key to improve the tool.
Okay, so that was just an introduction. There were many links, many screenshots. Don't worry if you are not familiar with it, because we will, of course, go through all the relevant links, resources. We will show you really everything you need to know about the tool. The video is also on YouTube, so when you have the slide, you will be also able to find it online. Now, let's start with the ETF testing framework. As I mentioned before, this is an open source tool. The development started in 2010. I will show you a bit of history in the next slide. Current version is 2.1. You will see today you can use the ETF either through a web application, but also through a REST API. If you want, for example, to automate tests, you will have test reports that actually tell you how well your resources are. Or behave according to specific technical requirements in different formats: HTML, JSON, XML, CSV, and you can test a wide array of resources using the ETF. First of all, data sets, including very large data sets up to really several hundred gigabytes. That, of course, depends on the permissions, on the parameters that you set. You can validate XML, GML data sets, shapefile or CSV data, XML metadata, and then services. So view services, WMS, WMTS, download services like Atom feeds, WFS, WCS, SOS, and catalog services in CSW. Of course, I assume you are all familiar with these acronyms. If that is not the case, feel free to ask in the chat. Some history of the ETF and some key milestones. So as I said, the development started in 2010, thanks to a German company that is called Interactive Instruments, GmbH. They developed the very first rough version of the tool that at that time was available only as a command line tool to support member states in a sort of a preparatory project for INSPIRE. That was the European Spatial Data Infrastructure Network. In 2015, version 1.7 of the application was released. This was the first version with a web user interface and with test reports in PDF format. And the idea was here to help German member states to validate their 3D building models in the CTGML encoding. Then in 2017, the JRC, so the European Commission, came also and started to use and to further fund the ETF and reuse it for the INSPIRE Reference Validator, which is clearly topic of today's training. In this case, the software became a little bit more mature, and the tests were added for other services and other, let's say, data types or data models, of course, in this case, addressing the requirements of INSPIRE. That was version 2.0 of the software. In 2020, there was also another implementation for the ADV in Germany, so for the surveying agencies of the German federal states. And finally, in 2022, a significant milestone, because the ETF also was somehow moved under the umbrella of OSG, or the Open Source Geospatial Foundation, which is the international foundation supporting the development, the use, the adoption of open source software. And these happened through let's say, process to become an OSGeo community project, and also a process to be featured, to be included in the OSGeo Live. I will cover these in the next slides. And that was version 2.1 of the software, which is still the latest version, released in 2022. Back to the software. I said open source. It's open source under the European Union Public License, version 1.2. This is basically the license used for software developed by the EU institutions. All the code, but not only the code, also, let's say, repositories for community interactions are available on GitHub. So there is an organization, so github.com/ETF Validator. So this is the organization where you will find all the repositories. And there's a website, etfvalidator.net. The ETF was basically designed with some goals in mind. The first was to be user-friendly. The idea is that you don't need to be an expert or a developer to be able to use the software. So you should be able to easily select the tests that you want and to interpret and to understand the test reports that hopefully allow you then to fix, to improve your resources. It is consistent with the standards, so the notions in the ETF align with ISO 19105, geographic information conformance and testing, but also with the OGC specification model. And as I said before, the idea is to be able to test all resources in an SDI. There are manuals, so there is documentation available for users, developers, and administrators. These will be comprehensively shown later on in the training this morning. More on the technical side, but once again, this is just a high-level overview, and then we will dive into the details later on. But when you have an ETF, you basically have different components. There's always a database that stores information such as test reports, such as information on the test objects, information on the test runs, so the actual tests run by the users. There are one or more test engines, depending on what you need to test, and a servlet container to actually run your application. We currently have 3 test engines to execute ETS. ETS was mentioned in the video. Executable test suites. Again, we will come to this concept later on. These are the actual tests you want to run in the software. So we have SoftUI, which is a widely used tool for testing web services. As a disclaimer, this will be replaced soon with another test driver that will use domain-specific language, NeoTL, the Neo testing language that will allow to actually specify tests in a much more easy and understandable way. So this will really facilitate the maintenance, the understanding of the tests, the efficiency actually in the process. But for the moment, there's still SoftUI. We have BaseX, which is an XML database to test XML resources, so metadata, but also GML datasets. BaseX also makes use of a sort of a plugin called GML GeoX to execute geospatial processing. And this is based in turn on open source component that you see here. JTS, so the Java Topology Suite, and Degree, very, I would say, well-known open source libraries. And we have also Team Engine, which is basically the tool that is used by the OGC in their compliance testing program. So with this test engine, the ETF can basically call the Team Engine and execute tests by basically call tests executed by the OGC validator. The ETF is an open source project, and as such has its own governance system. There are 2 main governance bodies, the steering group and the technical committee. The steering group is, for the moment, formed by basically the 2 representatives of the 2 organizations that are behind the main funding and development of the software, the JRC and Interactive Instruments. Basically, we take decisions by consensus, and the idea is that we discuss regularly on the future of the software, on potential improvements that are described as ETF improvement proposals, or EIPs, and for each EIP we discuss, of course, we decide whether there is agreement on its implementation, and clearly discussions on who is going to fund it, who is going to develop it, and in which version of the software it is going to land. It's an open process in the sense that you can follow the whole discussions from GitHub, and of course it's an open source project, so whoever has interest in the software, including in funding the software, is very welcome, of course, to contact the steering group. The technical committee is clearly responsible for more technical tasks. It is composed of people with a proven technical capacity and knowledge of the ETF. The technical committee provides feedback on the EIPs and is responsible for merging pull requests and preparing releases of the software. On the right-hand side, you can see the screenshot of the README file of the governance repository, which is one of the repositories within the ETF validator. Now, I mentioned before that we have recently moved the ETF under the umbrella of OSGeo, which is this foundation really supporting the development and the use of geospatial open source software projects. These are two screenshots of the OSGeo website. On the left, you see that ETF is listed as a community project, something that the ETF achieved, so a status that the ETF achieved in 2022. Community project means that the project is formally under the umbrella of OSGeo. There is a process to be somehow accepted as a community project. There is a specific committee within OSGeo that checks characteristics of the software, such as, for example, the open source license, clearly, but also the presence of a community of users, of developers, the quality of the code somehow. This is just the first level. Then OSGeo has a second level of projects, the so-called, let's say full OSGeo project that have to go through an incubation process, which is a bit longer. So we are not yet at that level, but still we are featured on the OSGeo website, and you can see some, let's say, high-level description and characteristics of the software. Similarly, always starting from 2022, the ETF is included in the OSGeo Live, which is a distribution, again, provided by OSGeo, based on a Linux operating system. It's Ubuntu operating system, which includes more than, I think, 50, 60 already pre-installed, pre-configured open source software tools for working with geospatial data. So I would say this is the best way for you, if you are a total beginners with the ETF, to actually try out the software, because the software is already there. You don't need any installation, any configuration. So you already find the software actually up and running and working. You just need to basically download and use the OSGeo Live, which is available as a USB stick, which is available as a virtual machine, as a bootable DVD, etc. So I would say if you have, if you need really to try it out for the first time, please consider this opportunity. There are also a couple of links in the slide which correspond to the actual documentation of the ETF in the OSGeo Live distribution. There is an overview which provides a very quick and short description of the software, and then a quick start, which is a step-by-step really training to, let's say, guide you through your first steps using the software. And I would say this is already quite complete and quite interesting as a documentation. This is updated basically every year. So every year in the new OSGeo Live version, you can find perhaps some differences compared to the previous year. Now let's move to INSPIRE, because as I said, the ETF is the open source software, and then there are implementations. One of these is the INSPIRE Reference Validator. Just for those of you who may not be familiar with INSPIRE, this is a directive from 2007 that basically created an organizational, a legal, a technical framework to share geospatial data across the EU to support environmental policies. So there are requirements on data sharing, there are requirements on data discoverability through metadata, on data accessibility through network services. And the idea of INSPIRE is not to be something created from scratch, but to be something created on top of the national spatial data infrastructures already developed by the member states. And to be more concrete here, there is basically a legally binding part composed of the directive and a set of Commission regulations or decisions, which overall go under the name of INSPIRE implementing rules. So these are legally binding because they describe what the member state must do, so legal requirements. These are then translated into technical guidelines, which are not legally binding, but they explain in technical terms how member states might implement the legal requirements. And we have technical guidelines for all the resources already mentioned: metadata, datasets, and network services. And this is where the validator actually comes, because given that to satisfy the legal requirements, member states have to provide resources, the validator is a very useful tool actually for several stakeholders. First of all, for the data providers themselves, because they can test the resources and they can check whether they are or not, let's say, conformant to the INSPIRE technical requirements. The validator is also a very useful tool for the coordinators of INSPIRE. So let's say the EU, so the European Commission, the JRC, the GM, and the European Environment Agency, so to check the level of implementation and the evolution of the level of implementation of INSPIRE, but similarly also for the same INSPIRE coordinators at the at the national level. We use INSPIRE Reference Validator since now 5-6 years also as the official, let's say, monitoring tool for checking the compliance of some of the INSPIRE resources. So this is the so-called monitoring and reporting process, which happens at the end of each year. So it has also, let's say, a very important role in defining, let's say, the official check to member states' resources. Finally, the validator is also used by solution providers to actually check that their software solutions are aligned with the INSPIRE requirements. Just to mention one example, in GeoNetwork, you can actually automatically check that your metadata record created using the software are, let's say, compliant with the INSPIRE provisions. And this is done through, let's say, a call to the INSPIRE Reference Validator in order to create, let's say, a real-time validation and then show you the results again within the software tool. And of course, similarly, there may be other software providers. Clearly, it's an open source software, so we might not even know who is using it and for which purposes. The idea, let's say, that was behind the initial development of the validator was to align the services and the efforts, the initiatives that were already ongoing at the JRC, but also in some member states. So to basically exploit synergies, to join forces, and to provide a central point of, let's say, validation in order to have consistent results and to be a sort of a reference for the whole INSPIRE community. So the validator was initially funded by the ARENA and the ELISA actions, respectively, under the ISA and the ISA Square funding programs, more recently also from the Digital Euro program, as you have seen in the video before. The idea is to clearly provide tests for all the resources that are mentioned and for which we have INSPIRE technical guidelines. And again, as a bit of history, we started initially with tests for data sets under the Annex 1 of INSPIRE, metadata, the, let's say, former technical guidelines 1.3, and download services, ATOM and WFS. Then over the years, we completed the set of tests with the new TG version of metadata 2.0, view services, download services, and discovery services. Then we completed the tests for Annex 2 and 3 data specifications. And then over the last 4 years, we added new validation requirements whenever these were needed, or whenever there was a need to actually translate into test requirements from INSPIRE good practices, so new standards, new approaches, new ways to share or to encode data. For example, OGC API features that has become an INSPIRE good practice, IX metadata, so this is for metadata for agricultural data sets, and then more recently the data service linking simplification approach that, for those of you who are familiar with INSPIRE, is something very important to actually facilitate the process of linking your data sets metadata to your service metadata. The requirements of the the INSPIRE Reference Validator were to be modular, to be reusable, to be, of course, open source, and to provide configurable test rules. Again, we will see everything in the next part of the morning. What are the components of the validator? So when we talk about the INSPIRE Reference Validator, we talk about a set of components, starting from the TG, which, as I said before, provide the requirements for all the INSPIRE resources. At the first level, these are translated into abstract test suites, or ATS. These are the high level or the abstract descriptions of the test cases. At the second level, these are translated into executable test suites that are really the lower level. So the executable, let's say the concrete descriptions of the test cases. So in other words, the code that is executed to actually run tests. And finally, the ETF, which I presented before, is the testing framework where the ETS are run. And when we speak about the INSPIRE Reference Validator, we actually mean the, let's say, composition of the three. So the ATS, the ETS, and the ETF. Now, let me move into a little bit of detail into each of the components. ETF, we have already seen. Now, ATS, or Abstract Test Suites. Again, you can see from the picture, we have a lot of requirements from the technical guidelines. All the requirements are covered by specific test cases, so specific, let's say, minimal units of tests, which are then grouped into so-called conformance classes. And conformance classes together form what is called an abstract test suite. So all the ATS have been, in the case of INSPIRE, developed by the JRC in agreement with INSPIRE MIG-T. Again, for those of you not familiar with INSPIRE, the MIG-T is the technical subgroup of the MIG, which is the maintenance and implementation group. This is the main governance body within INSPIRE and is formed by member states, representatives, and technical experts. In the past, there used to be a group, a subgroup of experts of the MIG-T, 2017.4, exactly responsible to supporting, to agreeing with the JRC, let's say, the development of the ATS. Now that the tests are more mature, more established, this group is no longer active, but still the MIG-T is, let's say, asked to intervene whenever there is, of course, need to do so. All the ATS are available on GitHub. In particular, there is one organization on GitHub, github.com/INSPIRE validation, that includes all the ATS. And in this case, we have one different repository for each ATS, or for each type of resource. So we have repositories for metadata, for discovery services, for view services, for download services, and then for different, let's say, categories of data sets ATS. So data specifications, which include the general tests on, for example, the consistency of the data, the presence of and the declaration of a coordinate reference system. So anything that is not specific to an INSPIRE data theme. Data encoding, which checks, makes tests on the GML encoding of the data, and then the theme-specific ATS for all the themes in Annex 1, Annex 2, and Annex 3. Then this is an example. So you see on the left, there's an extract from the INSPIRE technical guidelines. This is the one on metadata 2.0. So you see there is a requirement, and basically on the right, this requirement is translated into an ATS. So what is an ATS? You see, it's a simple description of what the test does. So in this case, you see there is a purpose. So this test tests that the spatial resolution is defined using either a scale or a distance resolution, which basically is what is written in the requirement here. And then there is prerequisites, if any, test method that basically says, okay, for each, in this case, spatial resolution element in the metadata, we check that these other elements exist. We check that all the children of this element are either equal to these or these, and et cetera, et cetera. If any of the checks fails, the test fails. So this already explains what is tested. Then the second part is how to translate this into something that is executable. So this is where the ETS actually come. The idea is the same. So you see, this is the same figure as before, but now there is a new piece here that where basically each test case within a conformance class is actually covered by one or more assertions. Assertions are, again, the smallest units of test, part of an executable test case, which is part of an executable test suite. Again, everything is on GitHub. In this case, there is one single repository called ETS repository, including all the INSPIRE ETS, so for the same categories of resources. These are available under the EUPL version 1.2, because this is, again, code. And there's an example. So on the left, you have the same ATS I showed you before. On the right, you have the corresponding ETS. Of course, you're not supposed to read the code, but just to understand that this is the actual code. So this is written in XQuery. XQuery is a language from the W3C that allows you to actually go into an XML document and extract elements or check the value of an element. And this is basically how the ETS are actually written. So you may want to, of course, have a look. Now, we have two instances of the INSPIRE Reference Validator. We have a staging instance that is the instance that we update very frequently, because as soon as there is a change, like a bug fix or a new feature, or, for example, a change in the UI, we update the staging instance. So this is really a new instance. Somehow on a daily or a weekly basis, you can find different things, actually, or changes in the test. And then we have a production instance that only includes the consolidated developments, the developments already validated by the community, and this is released only when there is an official release of the software, which I will come in the next slide. Since now 5 years, both instances are deployed on the cloud in order to, first of all, avoid dependence on the GRC infrastructure, to maximize the uptime of the validator, but also, of course, to improve the performance and to enable scaling when needed, in particular horizontal scaling. As mentioned before, you can access the validator through a user interface. This is the one you see on the left, and through a REST API that you see here on the right, documented using OpenAPI. I will not go into the details because you will actually see both the UI and the API in more detail later on in the training. Releases, I mentioned that the production instance is released at, let's say, regular dates or times over the year. We have 4 or 5 releases already scheduled. So every year we already define when we will have the releases for the next year. Typically there's one in January, one in March or April, one in June, and one in September. The idea is that all the releases are basically the same, with the exception of the September release, because in the September release, we only include non-breaking changes, so changes that do not actually break existing implementations. This is to allow member states, data providers, to actually prepare for the end of the year monitoring and reporting process. So in a way, after the June release, all resources passing validation after the June release will also pass validation after the September release, because again, we are not introducing breaking changes. Final slide is on the community support. We have a repository that is linked here called Help Desk Validator that includes basically all services, all information, news for the community. First of all, you can find sample resources that you can use. For example, there's a sample metadata, dataset metadata, service metadata. So if you need to start from scratch in creating a metadata record, you can start from there, because this is already, let's say, checked and tested. It passes validation. There are also training materials available. So you can see, maybe not very well, but you can see there is a folder here called training material, I can anticipate that this is where we will put all the training materials for this training. So please have a look. We have the release plan that I showed in the previous slide. That is outlined there, so you can find explanations, and also you can find all the releases, so you can download the actual code of the software. We have an help desk management strategy, so we explain what is the actual process that we use when there is a new issue or a new bug that is reported in the help desk. So this really explains how we manage, so who takes care, who has to validate, how we use, for example, the GitHub labels, etc. And there is the actual help desk service. So if you use the issue tracker of this repository, you can actually report an issue, report a bug, provide a new improvement idea or proposal, etc. And this is where actually we provide support to the community. So I stop here, and I anticipate if you have any question, let's say not for the training, but after the training, use the help desk that I have just shown. If you have more, let's say, general or high-level question, also feel free to drop an email to Jersey INSPIRE support.